Hello, everybody. Let's talk about good principles when defining a class. I've tried to list some that I think are common ones, and I've given some of my own names that I hope are evocative. So one source of truth, the idea is that if your object has a bunch of variables that describe facts about it, it shouldn't be possible for those variables to be in conflict with each other. There should only be one variable for each of the facts about your object. Your object should be responsible for its own values, for its own data. So you shouldn't let other parts of the code be able to change your variable values, especially because that allows the possibility that they might become contradictory with each other, or they might take on values that aren't defined for the type of object that you have. They might be nonsensical in some way. When you're defining a class, you're trying to provide a reusable model of something useful. So in this example, we have a circle. Imagine what things people might want to do with a circle and try and provide methods that would let them do that. And then use good naming is just always a good idea. So let's get into it. So if you haven't done so already, pause the video and look over this example class. First, just make sense of it. Look at the name of every single method. Think, what's that method do? Look at how it works and think, oh, does that make sense? Yes, I see how that works. Note any good ideas. I think there are some good things about this, but there are also some violations of the design principles. So try and decide which of these are getting violated and where. All right, so these will be in no particular order. The first is naming. So let's just look at the name of the class, circle class. Which might seem okay until you think about the fact that this actually is giving the name of the type of object you're trying to define. And it's awkward to call your object circle class, because your object is really just a circle. Like, look at what it would look like in a main to actually use this method. I would have to say circle class, my circle, equals new circle class, and then you give it some numbers. And the numbers aren't really important. But look at how awkwardly that reads. Circle class is not a good name for a type of object. Like, what I really have is a circle. So let's rename this. Let's just rename it to be circle. And that reads much better. Circle, my circle, equals new circle. So point one is name your class something sensible for the type of object it's supposed to be defining. Okay, the second thing that's a little bit weird about this, you might notice that area in the constructor here is never being used. It says parameter area is never used because my field area I set by actually calculating the area. So I do pi times r times r. So pi r squared is the way that you calculate area. So let's go ahead and delete that as a constructor parameter because it doesn't really make sense to have it. All right, so far so good. So one design principle we're violating is that our object is not responsible for its own variables. And that's happening because all of the fields are public. And what it means to be public is that those values can be changed from any part of the code base. So here I've created my circle, but over here if I wanted to, I could say my circle dot, let's set the radius. So my circle dot radius equals -100. And like there's no problem there. Because I'm allowed to treat radius just as any old variable. But we don't want to let that happen because in this example, I've set radius to be a nonsensical value, and circles should be responsible for their own values. We should actively prevent the possibility of radii taking on values that don't make any sense. So what we'll do is we'll make all of these private, and you'll see what happens when we make it private. So as soon as I made radius private, now it says one related problem, and it's talking about this. And over here, you see it says radius has private access in circle. And all that means is that we're trying to access a variable that is private to circles. We're not allowed to access that variable from anywhere else. We can access radius from anywhere inside the circle class. That's okay, because radius is part of a circle. But we can't do it out here. And that's what setter methods are for. So here in my circle, if I want to set the radius, I can't just change the variable. I have to say set radius. Of course, the way that I've written my set radius method, I can still set the radius to be something nonsensical. I can set it to be -100. But now that we're forcing all the other parts of our program to use a circle method, we can fix the problem. We can say if new radius is larger than 0, then we'll set the radius, otherwise we won't do anything. And so now we have set radius, and you can try and set it to negative 100, but the circle will prevent you from setting an invalid value for the radius. If this was actually in a production system, you might do something like throw an exception to let somebody know that they tried to do something that doesn't make sense. You could have this return a Boolean value to indicate whether or not the set was successful, and then over here we could check to see whether or not we could set it successfully. But for right now, I want to focus on the design principle that we are actively, like Circle is actively managing its own values to prevent bad things from happening. Okay, there's another issue though, which is when we first create the circle, we calculate the circle's area based on the radius that we constructed it with. So we gave it 4 as a constructor argument, and we make an area that fits. But if I'm going to set the radius to be a new radius like 5, notice that the area does not get recalculated. We just set the radius, but area is still area. And so this is an example of one source of truth. Radius and area are both measures of a circle's size. So really there's just one fact here. The fact is size. But the problem is we have 2 separate variables that should be connected together that are about size, and it's possible for them to have values that are contradictory. I could say, I could look at the radius and the area should be different and vice versa. So we don't want that to be able to happen. So I think a good solution here is let's just delete area. So now there's only one source of truth about the size of the circle, the radius of the circle. And so I'll delete this here. But now the problem is what happens if someone wants to know the area? Because, that might be a useful thing. In that case, a good thing to do would be you could just recalculate the area the moment you need it. So we'll just recalculate the area as pi r squared. If you wanted to keep, a different thing we could do is we could keep the area variable and just make sure that we recalculate it every single time we set the radius here. I think that's a little bit less good because whenever you have 2 different variables that that you have to remember to keep coordinated with each other, there's always the possibility that you might forget to keep them coordinated. Like you might, sit this code down and come back to it 6 months later, and you might forget that these are important to remain connected, and you might change one without changing the other. So I think that's why you have the design principle, one source of truth. If there's only one variable, you can't possibly forget, important things that you need to do because there's nothing to remember. So that's what I would recommend is just keep one variable. Okay, so far, so good. There's a lot of ways in which this object might be more useful. In particular, I'm looking at the choice of integer for xy coordinates. If you know specifically that these circle objects are supposed to be used in a context where the xy coordinates are only ever going to be integers and the radius is only ever going to be an integer, that's fine. I feel like it might be a more flexible object to make them doubles, in which case we would need to now return, we need to change a couple of things here. So these would have to be double when we're calculating distance. I think there's a whole bunch of other methods that might potentially be useful. So we have a set radius and we have a get area. It might be nice to have getters and setters for the center of the circle. Might be nice to have getters and setters for the radius. In IntelliJ or most IDEs, you can do this pretty quickly by typing. So I did Shift to pop open this context box, and then I'm going to search for getter and setter. And then here's getter and setter. And it should, nope, of course not. Hold on. Okay, getter and setter. So now I'm generating my own getters and setters. So I'll just select all of these, and it's going to create code for get x, set y, set y. You want to think for a minute, especially with setters, are we allowing ourselves to do something that would make the values of variables, take on things we don't want them to take on? Seems like the answer is no. Get radius seems fine. Set radius, we already have set radius. I don't want 2 of those. Okay, so that seems okay. Let's end with one more thing. A lot of programmers will tell you that you should never refer to your variables directly, even from inside your own class. You should always use the getter methods. So for example, here, when I'm calculating the area, I shouldn't ever say radius. I should always do getRadius and getRadius. And that might seem weird, like why run your own getters? Here's the sort of reason, and it's going to seem a little bit artificial for this like toy example. But we might decide down the road that we don't want the radius to be a variable anymore. Maybe the radius is going to depend on something else. So for example, let's pretend that we decide, all right, our circles are actually going to have a creation time, like the moment they're created. And then they're going to have a radius when they're first created, but that radius is going to get smaller and smaller over time. So in that case, we don't want the radius to just be the radius. We wish we had something like this. For getRadius, we would calculate the radius based on the current time. So I would do something like this. I would say, so current time equals system dot current time in milliseconds. And then I would calculate the radius. I wish I could say something like radius equals, I guess I need my initial radius. Hold on, I should have thought this example out. Okay, so I've got my initial radius, but then I want it to get smaller with time until it disappears. So I'll say, I wish that my radius was equal to my initial radius minus, some small amount for every millisecond past my start time. So I would say current time minus, what did I call my start time? Minus create time. So this is going to be how long since my object was created, and I'm going to, subtract things. So something like this. But what's awkward is, I don't have a single radius variable anymore. I could keep my radius variable, but how do I make sure it remains updated all the time? So what I really want to do is, if everywhere that I want to use the radius, I had been running the getRadius method, now I could actually get rid of the radius variable entirely, and every single time someone wants a radius, I could calculate what is the radius right now. But that's like a problem. I guess we would have to get rid of the set radius. But that's a problem because like down here, if I'm trying to check if it contains point, I'm trying to use a variable that I wanted to remove because I don't want this to be a variable anymore. I want it to be calculated based on something else. But if originally I had written it this way, now it works just fine because I'm fetching the radius the moment that I wanted it. And I'm letting it get calculated based on whatever the situation is. So that's the general idea. The general idea is anything that's a variable, later on you might want that variable to actually be calculated based on other things. But if you're constantly referring to it as a variable, that means that you can't really make that change without breaking everything because you have all this code that's referring to the name of the variable that you want to delete. So if you're always using methods, it's not a big deal because you can just change the inside of the method and say instead of returning a variable, we're going to calculate it based on other stuff. So that's another good design principle.